Okay, so we're going to talk about the alkanes and the alkenes. So first of all, both of these are hydrocarbons, which means they both contain carbon and hydrogen, and a different amount of carbon and a different amount of hydrogen in each one. And they are found in a mixture called crude oil. So first of all, let's have a look at alkanes. So alkanes have the formula CnH2n plus 2. And what this means is if you have, say for example, 2 carbons, so I'd put the number 2 here, I'm going to work out how many hydrogens I have by putting the number 2 here. So therefore, if I was to work out how many hydrogens I have, if I have 2 carbons with my alkanes, is I would have 2 times 2, as in a 2 and an n next to each other means 2 times 2 plus 2. So therefore I would have C2H6. So using the same formula, if you pause the video and tell me how many carbons would I have, or how many hydrogens would I have if I had 4 carbons. So just try that one. Okay, so hopefully you've done that and you'll appreciate that I'm going to continue using this formula. So that is Cn, and that's where I'm going to put my 4. 2n, which I'm going to put 4, and a 2 and a 4 next to each other means 2 times 4 plus 2 means that I'm going to have C4H10. So I could also do this the other way around. Let's say, for example, I had CnH22. So I want to use this equation to work out how many carbons I have if I know I have 22 hydrogens. So the first thing that I'm going to need to do is the opposite of what I've done here. So I'll have to minus 2. So now I have minus 2 and 20. And the opposite of what has happened here, which is times by 2. So I will divide by 2. So that will give me 10. So therefore I would have C10H22. So let's just recap that as a step there, in a step-by-step process. If I know how many hydrogens I have, say for example if I had 44, and I want to know how many carbons I need to have, first thing is I will minus 2 as my first step. Second step, I will then divide by 2. So in this case, minus 2 would bring me to 42. Dividing by 2 would give me 21. Okay, so if we have a go at pausing the video and having a go at this one, so if I had C unknown H8, could you please work out how many carbons I'd have? Okay, so hopefully you've done that. So in this case, I would have minus 2, which is going to be 6, divided by 2, which is going to give me 3. So I would have had 3 carbons, 8 hydrogens. So the first 4 alkanes that you need to know about are M, E, P, B. So methane, ethane, propane, and butane. So methane is C1H, and so I don't need to write a 1 there because just C by itself means 1. H, 2 times 1 plus 2. 2 times 1 is 2, plus 2 is 4. So that's methane. Ethane is C2H something. Propane C3H something. And butane C4H something. If you just quickly have a pause of the video and just work out how many hydrogens there would be in each of those. Okay, so if you've done that, 2 times 2 is 4, plus 2 is 6. 2 times 3 is 6, plus 2 is 8. And 4 times 2 is 8, plus 2 is 10. So if I want to draw these out and show the structure of them, then methane is going to look like this. And that one line means that you've got one covalent bond between the carbon and the hydrogen sharing one pair of electrons. Ethane is going to look like this, with hydrogens around each carbon like so. And often what we sometimes say about the alkanes is we say that they are saturated. And the reason why we say that they're saturated is because all of the carbons are surrounded by hydrogens. So we just pause the video and have a go at seeing if you can draw what propane should look like. Okay, so hopefully you've done that. Propane is 3 carbons with hydrogens surrounding the 3 carbons like so. Okay, so one of the properties of alkanes is as they get longer, their boiling point increases. And a reason for that is that if you have, say for example, a beaker here with a load of short chain hydrocarbons in like this, the force of attraction between the molecules is slightly less. So we say it's less intermolecular force. Whereas if I have a beaker with long chain hydrocarbons in, the force of attraction between the molecules is greater. I have a greater intermolecular force, so therefore I end up with a higher boiling point, as it is harder to break these in a solid into a liquid and then a liquid into a gas. So we just need to recap on that. Which one has the highest boiling point out of methane, ethane, propane and butane, and could you explain why? So have a go at pausing the video and doing that. So hopefully we explain that butane has the highest boiling point as it is the longest molecule, so therefore has the strongest intermolecular forces, and therefore breaking forces between those molecules to turn it from a liquid to a gas requires more heat energy to enter butane. Okay, so often what we end up having is we end up having a situation where crude oil we extract from the ground and carry out fractional distillation, which is on another video if you look that up. And from fractional distillation we end up accumulating different length hydrocarbons. Now the short chain hydrocarbons we end up using as gas for cooking, and the long chain hydrocarbons we can end up using for stuff like tar in roads or bitumen when it comes to making paints, etc. Medium chain hydrocarbons, sometimes we have kerosene or diesel. Now often there is quite a high demand for the short chain hydrocarbons for gas and fuel, and less of a demand for the longer chain hydrocarbons. And so therefore we can carry out a process called cracking. And cracking takes a longer chain hydrocarbon and then it cracks it and produces shorter chain hydrocarbons. And this can be done either with the use of steam or the use of a catalyst. So let's say, for example, if I had C10H22, which is an alkane, and I wanted to crack it, I would end up creating C5H, let's say 12, plus also what here and what here, based on what we started with. If you pause the video and have a go at explaining that. Okay, so if you've done that and you realise that I must have 5 carbons here, if I started with 10, 5 are here, so therefore I will have 5 carbons here. 22 has gone, 12 have been used, so therefore I will have 10. Now this here is an alkane, and I know that because it undergoes or it conforms to the alkane formula. So that is CnH2n plus 2. This here, however, is not an alkane. This is what we call an alkene, commonly known as unsaturated. Now the alkene formula is slightly different. The alkene formula is CnH2n, but without the plus 2. So if, say for example, I had an alkene which was C6, it would therefore be what? Just pause the video and see if you can answer that. Okay, so hopefully you've done that and you realised it would be C6H12. Then I have to have a little bit of a think about how I go about actually representing this as a structured molecule. So let's draw this out down here. So 1, 2, 3, 4, five carbons, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we can see already is we can see that it is unsaturated because not all the carbons are attached or combined with bonded to hydrogen. You're missing a hydrogen here and you're missing a hydrogen here. And that's very important because this bond here, which should be coming out here, and this bond here, which should be coming out here, will end up forming a double bond in the molecule. So alkenes are not only unsaturated, they also have a double bond. So let's say, for example, I was to look at the first three alkenes. The first three alkenes are going to not starting with ethene, because I can't get ethene. I can, however, get methene. Oh, sorry, I can get ethene, that's my mistake. I can't get methene, but I can get ethene. I can get propene, and I can get butene. So ethene would be C2H4, propane would be C3H and butane would be butene, so it would be C4H. So pause the video and have a go at doing that quickly. So hopefully you've done that. C3H6, C4H8. Now if I was to try and draw ethene here, if you pause the video and have a go at doing that. Okay, so hopefully you've given that a go. So I've got 2 carbons with 4 hydrogens, like so, and then I have a double bond in the middle between those 2 carbons. Then if I was to have a go at drawing propene, well, propene is going to be 3 carbons, 1, 2, 3, and it's going to be having 1, 2, 3, 4, 5, 6. So if you pause the video and have a go at drawing or pointing out where you think the double bond should be going. Okay, so I hope you've done that and you realise the double bond is going to go here. Now this double bond here is often what we call a functional group. And the reason why we call it functional group is because it ends up being involved in various reactions and it gives the alkenes its properties. Now what an alkene can do is an alkene can react with other atoms. So let's say, for instance, if I was to have, I'll just get rid of this here. If I was to have a situation where I had an alkene, so let's say, for example, I had this alkene here, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. First of all, actually pause the video and see if you can firstly put the double bond where it needs to go, and secondly also tell out loud what this actually is called. Okay, so hopefully you've done that. You realize double bond needs to go here, and that also we are going to call this 1, 2, 3, 4. So therefore, if we can remember, we have no methane, but we do have ethene, propane, and and butene. And this is going to be butene C4H8. So if we have butene here, what we could do is we could add hydrogen to it. Now if we added H2 to it, what would end up happening is that this bond here could then reform with both of these hydrogens, so that we'd end up creating what? If you pause the video and have a go at saying what this is now called. Okay, so hopefully you've now realized that what we have done is we have formed butane. So we've formed butane from butene by adding hydrogens, adding H2. So therefore I have turned an alkane into an alkane. And that's called an addition reaction. It's also the case that what I could do is I could add, instead of hydrogen, I could add something else like, say, for example, chlorine, or say, for example, bromine. And let's imagine I added chlorine. If you pause the video and try and draw out what you think would be the result of this reaction. Okay, so hopefully you've done that and you realise that we will have Cl here and Cl here. And what we've ended up creating there is a halogen alkane. So we end up having a halogen alkane. And we could do the same with, say, for example, bromine. If I had Br here, I would end up with the same idea, but with bromine here and bromine here, like so. So we can have two addition reactions. One, we can have the addition of an alkene plus hydrogen, and an alkene plus hydrogen ends up forming an alkane. And then we can have an alkene plus a halogen, and that's going to end up forming a halogen alkane. Other things we can do is we could have an alkene, and to the alkene we could add water, and that is going to result in the formation. So this is going to result in the formation of an alcohol. So let's say, for example, if I had ethene and I added water to ethene, I end up creating ethanol. So let's say ethene here, which if we can remember looks like so. Water, and my reaction is going to form ethanol, which has this formula CH. And my OH group on the end like so, which is my functional group of my alcohol. So let's say, for example, if I had propene plus water, I would end up forming an alcohol called propanol. So if you pause the video and have a attempt at trying to draw what you think propanol would look like. So propanol is going to have 3 carbons with our OH group on the end, and then our hydrogens like so. Okay, so if we just have a go at some recap questions on this. So first question is going to be, what is the general formula for alkanes and alkenes? So if we do alkanes and then below alkenes. Okay, so if you've done that, so let's CnH2n plus 2 is our alkanes, and then we have CnH2 is our alkenes. Okay, so let's see if we can name the first 4 alkanes. Okay, so first 4 alkanes are methane, ethane, propane, and butane. And then see if we can name the first 3 alkenes. So that is going to be ethene, propene, and butene. So let's see if you can draw ethane and then also ethene. Okay, so ethane is going to look with 2 carbons and it is saturated like so. And ethene is going to be 2 carbons unsaturated, so therefore containing a double bond like so. Okay, so can we try and remember which one out of the following would have the highest boiling point and why? So hopefully we are aware that it would be butane, and the reason for that is the larger intermolecular forces, because it is a larger molecule which needs more heat energy to be transferred to butane in order to turn it from a liquid to a gas. Then we'll have, if I have an alkene here, so let's say, for example, I had ethene and I added hydrogen, I would form what? If I had ethene and I added a bromine, I would end up forming what? And if I had ethene and I added water, I would end up forming what? These are my addition reactions with the alkenes. So in this case, ethene plus H2 would give me ethane. Ethene plus bromine would give me a halogen alkane. And then I would have ethene plus H2O would give me ethanol. So if you also just pause the video and just have a go at drawing what you think butanol would look like. And then once you've done that, see if you can also have a go at drawing what you think propene plus Cl would look like, number 2. And then let's also just have to finish off, what does methane structure look like? So if we go butanol, so butanol is going to be 4 carbons with our functional OH group and our hydrogens surrounding. Next one is going to be our propene plus Cl, which is going to give us our halogen alkane. So propene is 3, and we would have had the double bond here. So what ends up happening is that we'll have the Cl here, like so. And then finally, if I was to draw methane, then methane is my H and my C, like so.